First example, we are going to look at, we're not going to look like a series, are we? We're going to find the sum from R goes from 1 to n, and just reminding you guys that for a series you can find values going from 1 to n, you can find them going from 1 to 10, you can find them going for a section of the series from 10 to 20, or you can find them involving only arbitrary values. From n going from 1 to infinity is all another type. So you have many different values that could limit our series. Please take note of them when you are doing your questions, all right? Because sometimes we have to apply different rules based on the particular question we are getting. Now, how do you approach a question like this? Remember, we have those basic rules that says you can find the sum of r, and that's just given by n plus 1 over 2. And you have these basic rules that you can memorize and you can apply. But in a question like this, you notice that we don't have, there's no way in this question we can perhaps separate these values where we have r squared that stands by itself in particular. We have a chunk in our denominator. We can't separate these terms, but we can use a substitution. But what we can do is we can try using partial fractions to see if we can separate this out into a more simpler form to work with. And the denominator, you should be able to recognize that's the difference of two squares there. So my first step in trying to apply doing this question, just erase that. My first step would probably be to rewrite this as 1 over difference of two squares, 2r plus 1, 2r minus 1. That's step 1. So this is the thing about when you're doing pure maths, you really have to be able to see past the structure of the question. So your mind should be thinking along those lines of partial fractions. We are going to set up our partial fraction here into the form a on, these are linear non-repeated factors, so it'll just be on a on 2r plus 1 plus b on 2r minus 1. The order in which you perform this would not matter. You could have had 2r minus 1 by 2r plus 1. Doesn't matter. Step 1, when you're doing partial fractions, you want to multiply across by the entire denominator. And multiplying across, you will get 1 is equivalent to multiplying across. You will get just a simple cross multiplication, a by 2r minus 1 plus b by 2r plus 1. Also, what we're going to do at this point is solve for those values of a and b by substituting values at when these values go to 0. So 2r plus 1 is going to go to 0 when r has a value of negative 1/2. So when r is negative 1/2 and we substitute it into our standardized equation that we have generated here, what will we get? Well, when r is negative 1/2, if you were to substitute that value here, this goes completely to 0, and you will get 1 is simply equal to, r is negative 1/2, that's 2 multiplied by negative 1/2, cancels, you just get negative 1. So that's 2 minus 1. 2 multiplied by negative 1, that's negative. That's 2 take away 1. All right, so over here, we should just simply get a value of negative 2a, I believe. So therefore, we're going to get a just being equal to negative 1/2. All right, and let's see what happens when we have the case at r being equal to positive 1/2. What are we going to get? Well, on the left hand side, we will get 1. On the right hand side, when we have r being equal to positive 1/2, you can see this just goes completely to 0. So you will get b. When r is equal to a half of 2 is just 1, 1 plus 1 is 2, you'll get 2b. So that implies that b is just simply equal to a So we have our values there. Now we're going to put them together. So all of this working just simply implies that our sum from r going from 1 to n of, remember our original question is 4r squared minus 1, works out to be the sum r going from 1 to n of, when you split into partial fractions, let's see, a is negative 1/2. So this is negative 1/2 all over 2r plus 1 plus b, and b was positive 1/2 all over 2r minus 1. All right, so no matter which substitution you try first, you should have this consistent separation into partial fractions, where the negative half is related to the denominator of 2r plus 1, and the positive 1/2 is related to the denominator of 2r minus 1 in any order. Right? We can simplify this. We can pull out that half, because if you have a constant, just like integration, you can pull those constants in front and they do not affect your question. So what we are going to do here is we are going to bring out that half in front, right? So bringing this down here, our original question will lead us to get a half. The summation as r goes from 1 to n of, what I'm going to do is rearrange this so that my positive is written first. If we pulled out the half from here and here, we are left with 1 over 2r minus 1 plus, subtract, subtract 1 over this side, 2r plus 1. So take a breather, understand what just happened there, make sure you did not make any mistakes, and that you understand that you are finding the sum of all of this that's contained within brackets. Now this represents a subtraction of two functions. So what we can apply is method of differences. This is how you know to apply method of differences. It's usually the you're finding the difference of two functions, right? So by applying the method of differences here, we're going to test to find out which terms cancel, which terms remain, because in the method of differences, sometimes it's not always the first and last term that remains, right? So you want to try the first three values when r is 1, when r is 2, when r is 3, and you want to substitute the last three values as well, right? So when r is n minus 2, when r is n minus 1, and when r is n. Those are the 6 values you would need to test to make sure sufficiently you know which parts are getting cancelled, right? So when r is 1, and we substitute 1 into this entire partial fraction, what will we get? Well, when r is 1 here, you'll get 2 take away 1, that's 1 over 1, which is 1. Subtract. When r is 1 again, that's 2 plus 1 is 3. So you're going to get subtract 1/3, right? Similarly, when r is 2, you're going to get positive 1/3 minus 1/5. Going down, you're going to get 1/5 minus 1/7. Let's see what's happening on this side. When you have r to be n minus 2, right? If I were to do a little bit of working in my column here, you have 1 over 2r minus 1. So when this is n minus 2, right, you will have 2 by n minus 2. That's 2n minus 4, and then remember you have to bring down that minus 1, right? So bringing it down, making no mistakes, you're going to get minus 1 is minus 5, so you're going to get 1 over 2n minus 5, subtract. Over here, when n is n minus 2, you have plus 1, so this would have just been a plus 1. You'll get 1 over 2n minus 4 plus 1 is minus 3. All right, and you just want to make sure that when you're going down the road, you sufficiently do enough expansions so that you do not get any cancellations happening that you don't know about. All right, when n is 1, you'll get this. Now let's check for the pattern of what cancels. So we correctly substitute. Now substituting these values of 1, 2, and 3, n minus 2, n minus 1, n, they can give errors if you make little mistakes. Sometimes, you can just add and subtract wrong. Those are minor errors that involve you taking your time, as well as basic algebra errors. They do not test your ability to apply method of differences, nor they do not test your ability to understand series, right? Those are just basic errors that you may make. So sometimes in working these out, if you find things are not canceling, it may do you well, very wise, to try and redo some of these parts just in case things are not canceling. Chances are you would have made a mistake somewhere. If you try the second time, well, then that's actually what it's working out to be. Okay, I'm getting tongue twisted today. Oh, could it be because I really woke late doing a session last night? Maybe. Anyway, let's see what cancels. So you have minus a 2 canceling here. And then I guess if we did r equals 4, this one will cancel. So it seems that all our central terms are canceling except our first term. And down here, if we observe, you'll see these terms just going. So I'm guessing if we did a n minus 3, this term would cancel with the one before it. So it seems that for this question, we actually do have that first and last term remaining. So if we bring together as our final answer, you would end up getting that. Originally, we had the summation as r went from 1 to n of our question was, we brought the half in front, right, of this partial fraction, 1 over 2r minus 1 minus 1 over 2r plus 1. And when we substituted values into here, we got 1. So this method of differences gave us 1 minus 1 over 2n plus 1. And of course, that's for what's contained within the brackets. Remember, we had a half outside, so we have to bring that half back in. Where did the summation sign go? Well, the sum involved use of method of differences. So we did actually finally use method of differences to find the sum. This is adding, this is finding the sum. So we have found the sum to actually be just 1 minus 1 over 2n plus 1. So the summation sign disappears because you actually, what's contained in this bracket here is the sum of all of this, right? So your final answer just simplifies to be a half, open bracket 1, subtract 1 over 2n plus 1. You may find a common denominator and have a numerator here. If you choose to, you may also expand brackets by bringing in the half and getting a nice 1 term. All of those answers would be correct in any form you choose, but this answer up to here is pretty okay for now. So that's how to work out a question like this. Let's move on to another one, shall we? All right. Let's consider a next question. Second one. What if they told us let a function in terms of r be given by 1 over r squared? Okay, and they're asking us to show that f of r minus f of r minus 1 is given by 1 subtract 2r all over r squared by r minus 1 all squared. Well, this is a proof. So we'll start off our question by proof. All right, so they want us to show what? They want us to show that f of r minus f of r minus 1 is going to give us this. So we have to use what we have on the left-hand side and try our best to get this. This is like working towards your answer. I love proofs because you already know what the answer is going to look like. So we are going to use what we have on our left-hand side and work towards getting this. When we get this, we are successful. So let's look at our left-hand side here and what else the question has to offer. Well, it did say f of r is 1 on r squared. So hey, we have something to work with. And by extension, if f of r is 1 on r squared, then f of r minus 1 must be r minus 1 squared. Hey, we have somewhere to go. Let's find the LCM. Finding the LCM will give us, I can see our answer happening right here. We already have the denominator, so we're going on the correct path. R squared into this will give us r minus 1 squared on your numerator. Subtract. This into this gives us r squared. So you have r squared on top. Let's see. They have a simplified version on top, so let's try expanding our numerator. You get r squared minus 2r plus 1, and then you have your minus r squared here. Yep, you can see those two cancel, and we already have our answer in the requested form. So that's a proof right there. We're done. They have 1 minus 2r, we have minus 2r plus 1, which is the same. You can rearrange and write a final statement if you like. This one was kind of simple, pretty quick, pretty easy. All right, so sometimes the questions are scary. You just have to begin working. Just begin working. When you have those proofs, begin working from one side and move your way up, and you won't believe how much you actually know. All right, so the next part of this question says hence, right? They're saying hence find the sum from r going from 1 to n of 1 minus 2r on r squared by r minus 1 squared. Now, previously in this question, we found that this was actually equivalent to the sum from r going from 1 to n of, what was it? It was f of r minus f of r minus 1. That's what we just proved. Just prove that this is equivalent to this. Okay, so because we actually found a kind of method of differences format, what we are going to do is apply the method of differences, and we are going to see what's happening here. Right, so applying the method of differences, you can write that down. Once you apply the method of differences, it means you are actually finding the sum, so the sign disappears. Applying method of differences here. Okay, let's see. Let's try all the different values. Now take your time for this question, because this question was a bit of a fuzz. We have to apply values. Now, usually you would apply values for r from 1, 2, and then 3. And then so on for r from n minus 2, n minus 1, and then n. Now for this question in particular, you would have to shift your limit values a bit. I'll tell you why. If you were to apply, when r is 1, for example, you would get, substituting into here, by the way, right, we would get f of 1 subtract f of, when r is 1 here, right, that's 1 take away 1, which is 0. You get f of 0. And remember, because you want those values to be positive, greater than 1, you would actually not be able to use this solution because it's not part of your solution. You do not have values for any of these, so you would have to shift your series for when r starts actually from a value of 2. So this is kind of like invalid. So that entirely just gets cancelled. So cases that when you apply the method of differences and you're getting your f value to be less than, remember this case method of differences applies when your lowest value is f of 1. If you encounter a value of f of 0, you want to eliminate that possible part of the sum. All right, just eliminate it. So for this question, we're going to readjust our limits from r going from 2 instead to n to entertain our answer, and then we're going to start from 2, right? So that's one point to note if it ever happens, right? All right, moving forward. So we have f2, subtract, when r is 2, you'll get 2 minus 1 is 1, subtract f of 1. Then continuing, when r is 3, you'll get f of 3, minus, when r is 3, you'll get f of 2. If you need to do a next one, just observe what's happening. You can, because over here you're wondering, would anything else cancel? Let's see. Let's test it. So let's include one more. Let's include when r is 4, just to see. You'll get f of 4 subtract f of 3, right? So let's see what cancels, by the way. We get this going with this going with this. Yes, so it would seem this would go with the next term down here. So what we have remaining on this side is a negative f of 1. All right, and on this side here, let's see what's happening. Let me just shift my board a little bit over here and taking your time with these questions. When r is n minus 2, you'll get f of n minus 2, subtract f of, when you have n minus 2 minus 1, you'll get n minus 3. Continuing, n minus 1, subtract f of n minus 1 is n minus 2. And then finally, when you have n, you just get f of n minus 1. Let's see what cancels, shall we? We have the f of minus 2 canceling there. You have, surprisingly, your last term that usually remains gets cancelled. Do you see that? So the cancelling is happening in this order here. So therefore, this term would cancel with whichever one is here. So what we have left is actually f of n. And bringing it together, here's how we bring our answer together. I'm trying to get it all on one page so you can completely understand. So our setup began with, we had to find the sum from r starting from 1 to n of this. And it said it was equivalent to this form. We applied method of differences because it's in that standard form. Applying method of differences using that expanded sum form, the sum of that is actually simply equal to negative f of 1 plus f of n. And if you had to rewrite this, you can write the f of n in front and we can remove that. Right? So therefore, what we can say is that the sum of from r starting from 2 to n of this original function 1 minus 2r all over r squared by r minus 1 squared is equal to this. The summation sign disappears because this is actually the sum of all these terms when it was finally expanded, right? Now, we could leave our answer like this, f of n minus f of 1, or you can actually go on to use, remember from the beginning of the question, they gave us that f of r was given by 1 on r squared. So you can actually use this and you can substitute these two values if you wanted to further simplify your answer. So there's some numerical values involved. You can substitute n here, so you get 1 on n squared, and you can substitute 1 here. So that's 1 on 1 squared, which is just 1. All right, so that's your final answer in the form n annual constants, right, of your sum. So a question like this, working all the way to the end here, is correct. And you can go ahead back in your final answer and expand your original limits back to r equals 1 to n of your original question, because the question automatically corrects itself for values not being valid from r going from 1 to n. Okay, so you can revert back in your final answer with r starting from 1. All right, and that's how you would work a question like this. Note that these double arrows are simply just bringing this function down because I was just being a bit lazy to write it over. Okay, guys, so that's the answer for a question like this. Let's see if perhaps we can do some more. All right, let me just clear my board here. Scroll back to the top. All to the top. All right. All right, so let me look for a nice question that we can do here. Actually, let's look for one with a actual sum to infinity question. All right, let's try this one, number 4. All right, so I'm going to skip over number 3. All right, so in this question, this is our third question that we are doing together. We have that they have given you that 1 over r cubed, subtract 1 over r plus 1 cubed. So immediately you can tell you're seeing either this is a partial fraction already split up, or this is a method of difference question, right? So they said it's equivalent to 3r squared plus 3r plus 1 all over r cubed by r plus 1 all cubed. So that's what the question has given us, right? So what they have done is they have already split up this into partial fractions for you. Thank God, because they did have those repeated factors would have been very, very long for you to figure out these values, right? So the question says find the sum. Find the sum from r going from 1 to n of this whole chunk. I will write the chunk down. 3r plus 1 all over r cubed by r plus 1 cubed. All right, so we know that by default, if you're finding the sum of something, it's the same as finding the sum of it split into partial fractions, right? You want to use some big brackets here. And you guys should have picked up on a pattern by now. The purpose of splitting up a fraction into partial fractions is so that you can actually go ahead and apply that method of differences, right? Once you see that difference of two functions, you can successfully apply that method of differences. So applying method of differences, this should, at this third question, be getting easier and easier. Method of differences, we want to test if we substitute certain values, which parts of our sum is disappearing, right? So testing at r from 1, r is 2, r is 3. All right, on this side, the last 3 values when r is n minus 2, r is n minus 1, and r is n. So when r is 1, we'll get 1 over 1 cubed, which is just 1, subtract 1 over 1 plus 1 is 2, 2 cubed is 8. We can leave it any form 2 cubed if you like. I mean, you know, when r is 2, you'll get 1 over 2 cubed. Make sure you're consistent as well. If you converted this to 8, you could convert this to 8 as well. When r is 2, you'll have 2 plus 1 is 3. That's 1 over 3 cubed. Right, down here, that's 1 over 3 cubed minus 1 over 3 plus 1 is 4 cubed. Right, you can eliminate immediately. I like to do it all in one and then eliminate, but you know, it would imply this one would eliminate with the one below as well. So you're left with 1, right? And on the right-hand side, let's work with our last 3 terms. Observe what's going to disappear here. All right, so when we have n minus 2, it'll simply be 1 over n minus 2. And a frequent mistake students use is they would substitute n minus 2 into the first value and then by accident substitute the next value into the second half. Remember, this is one series, so make sure when you're doing your substitution of r being equal to a particular chunk, you do it into the entire series, right? Not in parts. All right, subtract 1 over, when we have n minus 2 plus 1 is n minus 1 cubed. Continuing, you have 1 over n minus 1 cubed minus 1 over n minus 1 plus 1 is just n cubed. This will be 1 over n cubed. And then finally, minus 1 over n plus 1 cubed. Right, let's see what cancels. This is going with this one is going with this, which will assume that this one will go with this one just before it. So we end up getting this in addition to its sign. So by the method of differences, we have found the sum of this series in brackets. And the sum of that series in brackets is simply equal to 1 subtract 1 over n plus 1 all cubed. Right? So if you wanted to write your answer in the correct form, you will just write back your original question, right? R plus 1 all cubed. And that there is your final answer. Now, what if the question asked us another part? Right? So you were able to successfully use method of differences to find the sum. Now, what if they ask us to find, say, find s to infinity. Find s to infinity and determine if it converges or diverges. How are we going to do that? Well, sum, remember we just found the sum here, so that would also imply that s to the n was given by 1 minus 1 over n plus 1 cubed, right? Because the sum of this sequence over here is also equal to 1 subtract that. So therefore, as n approaches infinity, you can see that the denominator here, infinity plus 1, will get very large, and then infinity cubed is even larger. It's so large that this over here will simply 1 over n plus 1 all cubed. As n goes to infinity, this would go to 0. It will get so sufficiently small. 1 over a huge, huge, huge number keeps getting tinier and tinier and tinier till it approaches 0. So this whole value just goes to 0. Therefore, what is happening here is that the sum approaches, the sum to infinity approaches 1, a value of 1. And because we were able to get that s to the n approaches 1, we can say that the sum to infinity is 1. Hence, the series must be convergent, as we were able to find a value or limit value to which the series is converging. All right, guys, so that's how to apply a case scenario where if they ask us, well, after you have used the method of differences to find the actual sum of the series, is the series converging? Is it diverging? You would just have to simply substitute values of infinity into this sum and see if at infinity, if this sequence is giving you a numerical value. If it gives you a value, then it's definitely going to be converging. And it also tells you at which value it's converging. It's converging towards 1. This is why finding sum to infinity is very, very nice and straightforward. So this session has been approximately a little over half an hour long. I have a full worksheet on these questions, 11 in total. If you guys would like to see more, you can just message me and we will just go through some more questions. Okay, so it was good to be with you. I hope you guys finally understood our series, and next video we will be moving on to principle of mathematical induction, or PMI. So thank you very much.